Hi, in this tutorial I will give you an overview of how you can use OPC with MATLAB and the Industrial Communication Toolbox. So here you see the contents of this tutorial. First a short introduction, then a short introduction to OPC, then how we can use OPC with MATLAB and the Industrial Communication Toolbox. Then I will provide different examples. First I will start with OPC DA and some examples. Next I will show some examples using OPC UA. So then let's start with our short introduction. So in this tutorial we will use MATLAB and the Industrial Communication Toolbox to communicate with different OPC servers. And we will go through some basic examples where we use first OPC DA and then OPC UA. So what do you need in this tutorial? We need different types of OPC servers. So in the first part we need an OPC DA server. You can for instance use Matricon OPC simulation server, which is an OPC DA server, a test server which you can download and use for free. For the OPC UA part you can use of course any kind of OPC UA server, but in this tutorial I will use a free OPC UA server called OPC UA Server Simulator, which is an OPC UA demo or test server which you can download and use for free. And of course you need the MATLAB programming environment, and then you need the Industrial Communication Toolbox or toolkit. So then let's start with OPC. So what is OPC? OPC is a standard that defines the communication of data between devices from different manufacturers over the internet or in a local network. And typically OPC requires an OPC server that communicates with one or more OPC clients. And in OPC we have different OPC standards. The most used and most common are OPC DA, OPC Historical Data Access, and OPC Alarm and Events. So these are the classic OPC standards, and then we have the newer standard OPC UA. And the good thing about OPC, it's straightforward to communicate with different applications or different devices from different types of manufacturers if both parts support the same OPC protocol. So basically in OPC we need one OPC server where typically the data are stored, and that OPC server can communicate with one or more OPC clients, or actually the OPC clients are communicating with the OPC server, and then the different clients can either read data from the server or write data to the server. And both the server and the client needs to use the same OPC standard, and that could be either OPC DA, OPC Historical Data Access, OPC Alarm and Events, or the new OPC UA, etc. So I was mentioning what we refer to as classic OPC, which is the quite old standards. OPC DA for direct access, we have OPC Historical Data Access, and then we have OPC Alarm and Events. We have also other protocol or standards, but those are the most common or the most used. And all these three protocols has now been merged into a new and the next generation OPC standard, which is referred to as OPC UA. So the main difference with what you call a classic OPC, which is OPC DA, OPC HDA and Alarm and Events, and the newer OPC UA. The OPC classic protocols was Windows only, and they was only working on or with the Windows operating system, while the newer OPC UA is a cross-platform standard that works on Windows, Linux, Mac, embedded systems, etc. And also the new OPC UA standard also put all these three OPC standards into one protocol. So if we earlier needed both OPC DA, Historical Data Access, and Alarm and Events, we needed three different OPC servers or at least one server that was supporting all these three protocols. While in OPC UA, all these three now are combined into one new standard, which is OPC UA. So then we need only one OPC server and one or more OPC clients that can easily communicate with other over internet, etc. Because also the new OPC UA, it's easier to use over internet because it doesn't rely on this old technology called COM or DCOM, which is part of the Windows operating system standard. So then next, let's see how we can use OPC with MATLAB. So in order to use OPC with MATLAB, of course, you can create something from scratch or use a third-party toolbox or something. But the best choice, I guess, is to use the Industrial Communication Toolbox, which is from the same vendor as MATLAB. And this Industrial Communication Toolbox supports both OPC, it supports MQTT and Modbus. And this is a quite new toolbox, and this also replaced the previous toolbox called OPC Toolbox, which previously had the communication with an OPC server, but now in the same toolbox, the Industrial Communication Toolbox, you can use OPC, MQTT and Modbus in one toolbox. And this Industrial Communication Toolbox is a new toolbox that was part of MATLAB R2022A and newer versions of MATLAB. So then let's start with the OPC DA, OPC Direct Access, and some examples how we can use and communicate with an OPC DA server from MATLAB using this Industrial Communication Toolbox. So in order to communicate with an OPC server, we will use in this tutorial use Matricon OPC Simulation Server. This is a free demo or test OPC server that supports the OPC DA standard that you can download and use for free. So we will use that OPC server in this tutorial, but of course you can use other OPC servers as well. So then let's start with a basic example. So this basic example will just read a single value from the OPC server. So let's open the Matricon OPC Simulation Server and the MATLAB programming environment. So the Matricon OPC server is already running on my computer, so I can just start this Matricon OPC Explorer, which is a software that comes with the OPC server, which is a OPC client that you can use to test the OPC server. So then just let's start with finding the Matricon OPC Simulation Server here in the list of available OPC servers. And note that this server only supports the OPC DA standard. And then I can connect to the server, just clicking this button, and then next I can click Add Tags. And then in this server there are existing lots of different tags. So I just click here under Simulation Items. You have different folders where you have different tags inside the different folders. If you want to both read and write data to the server, you can use the Bucket Brigade items, because all these items can be both used for reading and writing. If you only want to test and read some data, you can use the random items here. So let's start with this called Reel4 under the random folder. I click on this arrow, and then when this is selected, I just click OK, and then I'm viewing that specific OPC tag here in the list, and I can see also the value. And since this is a random tag, the value changes randomly with a new value approximately every second, like this. So let's now go to MATLAB and see if you are able to read the same value into the MATLAB programming environment. So now I have opened the MATLAB programming environment and I have already made the basic examples, which you see here on the screen. So let's go through the example step by step. So this example are using this Industrial Communication Toolbox, and that is part of MATLAB, which you can use in order to communicate with OPC servers like OPC DA and OPC UA. In this example, we will communicate with an OPC DA server, and then we will use the Matricon OPC simulation server. So here, let's start to connect to the server, and then I just use a variable equals to OPC DA, which is connecting to the server. Since the server is on my local on the same computer as I have MATLAB, I just type localhost. Then I type the name of the server, which is this one, which is basically the same as you see here in the Matricon OPC Explorer, which is matricon.opc.simulation.1. So this is the name of the server that you need to enter here, and then you just use connect in order to connect to the server. Then typically you need to create a group, because you can read the data from one or more items, and then you need to specify or just create a group, and the group can be whatever you like to call it. So I just call it demo group, and then I just add group in order to add that group into this group variable. Then I need to specify which OPC items I want to use. So I want to use this in the random folder. I use this rel4, which is the same I used here in the Matricon OPC Explorer, which you see here. So random.rel4. So that's the name of the OPC item, and then I just add it to the list using this add item, and then I'm ready to start retrieving data from that specific OPC item. So then I just use the built-in read function with the input argument, the name of the group, which is specified here and here. And then after using the read command, you can just get the value from the specific item using, so I put it into a variable called data, and then you just use data.value in order to get the actual value from that specific item. So basically that's all you need to do. Finally, you can disconnect and delete this object in order to clean up and disconnect from the server. So let's just run this example, clicking the run button, and then you see I get a value here. This is a random value, which is the same you see here in the Matricon OPC Explorer. So then I can just click run in order to retrieve a new value like this. Click run once more, and every time you see the value has been changed, because I'm now reading the random.rel4 item from the OPC server. So basically this is how you can communicate and read value from an OPC DA server like this, using MATLAB and the MATLAB toolbox called Industrial the Industrial Communication Toolbox from MATLAB. So let's summarize this example. So here you see the entire example. First, we needed to use OPC DA in order to connect to the server, where we type the server address, in this case the localhost, or here you typically need to type an IP address and the name of the server. Then you use connect in order to connect to the server. Then you need to add a group, and then you need to add one or more OPC items. So I added the random.rel4 and put it into the list, and then I just use read and then put it into a variable called data, and then just use data.value in order to put the specific OPC value into a new variable. And then I just need to clean up and disconnect from the server like this. So this is the first basic example. So then I just modify this example by using one of the built-in functions called browse namespace. So then instead of specifying the name of the tag, because typically you don't remember the tag name, then you can have this window popping up where you can select one or more items from this window. So let's go to MATLAB and test this example as well. So we are back in MATLAB, so let's just open this example. So the only difference here is I'm using this built-in function called browse namespace. So let's just run it. So now after a few seconds, after we are connecting to the server, this browse namespace pops up where I can specify. Here you see the name of the server. Then I go to the simulation items, random, and then select reel 4. Click on these arrows, and then I can select one or more items and put it into this list to the right and click OK. And then you see I will retrieve the value from this item. So basically the only difference between the first example and this one, here I use this browse namespace instead of just specifying an item directly like this. In the next modify example, instead of just getting the value, you can also get the timestamp, quality, etc., which is different OPC properties that are attached to the different items. So if you see this modified example, here I can type data.item ID, which is the item or OPC item name. I can get value, I can get timestamp, quality, etc. So let's just run this example. It's the same example, but here I just specify more and retrieve more information than just the value itself. So let's just run it. This after a few seconds, this browse namespace pops up, so I select the same tag, random, reel 4, and click OK. And then you see I'm now getting more values, or so first I get the item ID, which is this one. Next I get the value, which is this one, and then I get the timestamp, which is actually this part. So that's the timestamp, and then finally the quality, which you see here. So by just typing data dot the different properties here, you can retrieve more information than just the value itself. I will show you one final example here, modified example. So in this modified example, so here I have specified more than one item. So here I want to get value from two different OPC items. So the first is from the bucket brigade dot reel 4 and then bucket brigade reel 8. So then I can easily get the values from more than one tag. So then I just so let's just run it. So when I run it, I see you get this information here, but you can also click on the data here, and then you see I am retrieving now two OPC items like this. So both the bucket brigade reel 4 and reel 8. So let's go to the Matricon OPC Explorer and just select those two tags. So then I go here under simulation items, bucket brigade, and then I need to select, both this reel 4 and reel 8 from the list here. So then reel 4 and reel 8, and then click OK, and then you see those two in the list. So now they don't have any values, but here I can right click, I can write value. So this reel 4, let's type value 4, and for the reel 8, let's just type 8. So now we have two items here in the list. One is reel 4, which has the value 4, and then next reel 8, which has the value 8. So let's go back to MATLAB and just run our program once more, and then click on the data, and then you see we are retrieving those two values, and you see that the values are correct. Real 4 is 4, real 8 is 8, and then also see the quality, timestamp, etc. So also here in the code I can just specify if I want to put the values into two variables. So I have two variables, one called OPC data 1, then I just specify data parenthesis 1 dot value, and then next OPC data 2 equals to data parenthesis 2 dot value. Since this data is a struct with two elements, so this is element number 1 and this is the element number 2. Then I just specify 1 and 2, and if I run this code now, then you see I get 4, which is this one, and 8, which is this one. So the first one is the value from the real 4 tag, and this one is the value from the real 8 tag, like this. So now we know how to read a single value from the OPC server, in this case an OPC DA server. So let's take the next step. Let's see how we can continuously read from the server. So in the first example, or in the next example here, I will just use a basic for loop. So the program is almost identical, but I have introduced a for loop where I just read a new value, in this case every 10 seconds. And then finally I just plot the values in this plot. So let's go to MATLAB and just run this example. So here you see this updated example in MATLAB. So it's the same, you connect to the server, you create a group, you add one or more tags, and I have now introduced a for loop. It goes with 10 iterations, and then in each iteration it has a pause. So here I just select 2 seconds, you can have 5 seconds, 10 seconds, etc. And then when the for loop is finished, I just clean up and disconnect from the server and put it into a plot. So let's just run this example. And now hopefully I will connect to the server, read data from this, in this case, random.real8 tag inside this for loop. And when the for loop is finished, I will just plot the value. I guess it will take some seconds, because in the iteration there are a pause of 2 seconds, and finally we was able to retrieve all the values and plot the values in this figure like this. So basically this is how you can retrieve continuous values from an OPC server using a basic for loop. So in the next example, in example 3, we will also read values continuously from the OPC server, but we will use some of the more advanced features, which is part of the Industrial Communication Toolbox. So here you see the entire example. So here we don't need to use a for loop, because we use some of the built-in functions. So this toolbox automatically read data from the server at the time and the interval we specify. So then here I have specified log duration 60. This means that we should retrieve data from the OPC server over 60 seconds. Here you see the log rate. Here you can specify in seconds. Here I'll just specify 2 seconds. And then I find number of records. Just divide the duration by the log rate, like this. And then finally we just use the get data, where we have these specified properties as an input, and then by doing this we just use the built-in more advanced features and are able to continuously read data from the server, and when this duration time is finished, it just plots the value like this. So let's go to MATLAB and also see how this example can work. So we are back in MATLAB, and here you see the entire example. We connect to the server, we create the group, we add one or more tags, and then here's the new part. we specify the duration and the log rate like this, and then we just need to start acquiring, and then use the wait, and then you just use get data in order to retrieve data according to these properties. So let's just run the application, and then we just need to wait some seconds until the program is finished and the data will be plotted. And then finally, after, in this case, 60 seconds, we was able to retrieve the data and plot the values. So here you see we are retrieving data from the OPC server within 60 seconds, and the log rate is 2 seconds. So then we get a new point in this plot every 2 seconds. So basically, this example are using some of the more advanced features from the Industrial Communication Toolbox in order to read data continuously without using a basic for loop or a while loop. So next, let's go through some OPC UA examples. So in order to use these examples, we need an OPC UA server. So in this tutorial, I will use a free OPC UA server called OPC UA Server Simulator. The server is from Integrated Objects, and this is an OPC UA demo or test server which you can download and use for free. In addition, I will also use an OPC UA client from the same vendor, from the Integrated Objects, which I can use in order to test and make sure that everything works fine with the OPC UA server. And I can also use OPC UA client in order to write and read data. And so I will use these two software packages in combination with MATLAB and the Industrial Communication Toolbox. So here you see the web page from Integration Objects, where you can download the OPC UA Server Simulator. So you just go to the web page, click the download, and in order to install this demo server. When you have installed it, it will, and when you run it on your computer, it will look like this. So basically, you find the name or the address of the server here, which you need to use in your MATLAB program. And here you see the same for the OPC UA client, which you download from the same web page, which is a OPC UA client or an OPC UA demo client, where you can test and make sure that the communication with the server works as expected, and then you can also use it to test communication with the server by reading and writing data. So then let's start with some basic OPC UA examples and how we can communicate with an OPC UA server using MATLAB and the Industrial Communication Toolbox, which is part of MATLAB. So in the first example, I will show how you can read data from an OPC UA server. So here you see the basic structure of such a program. First, you can get a list of available OPC UA server using this OPC UA server info function. Here you can specify an IP address, or in my case I just type localhost to find all the OPC UA server which is available on my computer. Then I can connect to the server. So first I just use the OPC UA in order to specify the port and the address of the server, and then I just use connect in order to connect to the server. Then I can use this browse namespace. Then a window will pop up where I can select one or more OPC items from a list, and then I just use read value in order to read the value, timestamp and quality from the OPC UA server. And then finally you can just disconnect. So let's go to MATLAB and see how we can implement this example in MATLAB. So before I go to MATLAB, I just need to start the server. So then I type OPC UA. Then I have this OPC UA Server Simulator, which I need to start. So you're running a demo version of this server, and it will last for 48 hours. After 48 hours, you need to just restart the application. So basically, this is the server, and then we have this OPC UA client. So now we have both a demo server and a demo client, which we can use. So now on this OPC UA client, I need to connect to the server. So then I just copy the address to the server, which is here. Click on the connect button and just paste it and click apply. And then in the list here now, we will get access to the server, and then we will see all the items that are part of the server. So then I just go to real-time data, and then you see that the different tags that are part of this server. So then I can, let's say, use this tag number 7. Then I can right click, and then I can read or write values to this item. I can also monitor it, so then I can click monitor and subscribe, click OK, and then this item will be here in the list, and then you will be able to see the value. So then I can also change it, right? I can type 5, click OK, and then you see the value has been now updated. So though the value for tag number 7 is 5, like this. So now let's go to MATLAB and see if we are able to read the same value from this OPC UA server. So now we are back in MATLAB, and I have already created a basic example where I'm going to connect to that server and read the same value as we see here in this OPC UA client from integration objects. Then let's go through the example. Here I just create an object with the localhost or the specified IP address. This is the port number which I found here on the server. So then I can here under settings, configuration, and here you see the TCP port which this server are using. So then I need to use the same port number here. Then I can connect to the server. I use browse namespace in order to get this window where I can select one or more tags. Then I just use read value in order to read the value, timestamp, and quality from this item. And then I can just disconnect. So now I hope I will be able to get the same value, which is 5 in this case. So let's just run this example. And this window pops up where I can browse and select the specific item. So I select the same tags, tag number 7, put it to this list to the right and click OK. And then in the bottom here, I should be able to read the same value, which is 5 in this case. I can change it to another value. Let's change it to 8. And then you see the value has been updated on the server. And I can rerun the application. I need to select the same tag from the list. Typically, if you want to run this application many times, you don't want to have this window pop up where you need to select the same tag each time. And then you see in the list there the value should be here. The value now is 8. So then I can just modify the example. So instead of using this browse namespace, I can just specify the tag item directly like this. So then I just specify tag number 7. So by running this now, I don't get this pop-up window. I get the value directly without need to select the tag every time. So then I can change it here to 9. Go back, run it, and then you see I will get the updated value like this. So basically this is how you read data from an OPC UA server using MATLAB and the Industrial Communication Toolbox. So it's quite easy, just a few lines of code. You specify information regarding the server, you connect to the server, and then you specify the name of the item, and then you just use read value in order to read the value. And then you can improve this example by implementing a for loop, while loop, etc. So now we know how to read values from an OPC UA server. Let's see how we can write data to the same server. So basically in this example the code is almost identical. So the connecting to the server part and specify the item to use is the same. So the only change here is instead of read value I use write value. So then I just specify a value, let's say a new value 22.5 or something. Then I use the built-in function write value, specify the server and the item to write to and the actual value. So basically the code is almost identical. So let's go to MATLAB and see this example in action. So here you see the example in MATLAB. So this is the same. I connect to the server and specify an item, and here I just specify the new value and just use the write value. And also here in the same example, as first I write the value and then later I read the value. So then I just run it. And now in this example I'll use this roles namespace, so this will pop up. I select the same tag. And then since I first here write the value and here I read the value, you see I will get the value as that I was writing to the server, which is now 21.7. And also here in the OPC UA client from integration objects, you see the value has been updated. I can also go to the other example where I'm reading the value. Here I'll specify the same tag. And then you see also here the value will be 21.7. So basically this is how you both write values to the server, and here you see how you read values to the server from this OPC UA server from integration objects, but of course you can use any kind of OPC UA server. So that's all. So now we have learned how to use MATLAB and the Industrial Communication Toolbox, and you have learned both to write and read values to different OPC servers. We started with an OPC DA server, and then we finished with a newer approach, this OPC UA, and we was able to both write and read values from an OPC UA server. So thank you and good luck with MATLAB and the Industrial Communication Toolbox and your OPC communication. Thank you and goodbye.